or at least one like question 6. I don't know if you've noticed, it depends if you've done WebAssign before, but WebAssign randomizes the questions. And by that, it means that although the questions are very similar looking to each other, they use different numbers. That might be 6, that might be 25, you know, for instance. So that if you contact someone else in this class and ask them for help with the question, they won't be looking at the same question as you probably. So it's not going to be a perfect match if you were looking for help that way. Okay, now, this fella here is going to be my equation 3. He is called the constraint equation. And we typically call him g of x. And g of x is the x squared plus y squared guy, right? Now, according to what we need to do, we have to solve when is this guy equal to lambda this guy. And this fella here, which says that x squared plus y squared is less than or equal to, whoops, I don't know where that came from, less than or equal to 49. Right. If you do delta f, differentiate with respect to x, you get 2x plus 8. You do it with respect to y, you get 2y, take away 8. And that's going to be equal to lambda, 2x, and a 2y. If I take, compare the x components, I get my first equation, which is 2x plus 8 is going to equal 2 lambda x, and I call that equation 1. And my equation 2 is comparing the y components of these vectors. So that guy is going to be that. And equation 3 is your constraint equation, right? The whole package, including the less than or equal to 49. Can you see that sometimes that might be equal to 49? And sometimes it's less than or equal to, and sometimes it might be greater than or equal to 49. Isn't that the last hurdle that a possible solution has to get over? These two are going to generate x's and y's typically, and this one here we use the boundary to get the answer. So that's essentially the gist of what we need to solve. So we start off with making lambda equal 0 and see what that creates. Well, if you make lambda equal 0, equation 1 becomes 2x plus 8 equals 0, which means x could be -4. Equation 2 and becomes 2y take away 8 equals 2 times nothing times y, which is nothing. And that generates, I believe, y equals 4. So we now have a possible solution. And it's -4. So now we're going to test this guy on that constraint. And it has to have this property. Well, -4 squared plus 4 squared has to be less than or equal to 49. I can handle that. 16 plus 16 has to be less than 49. 32 has to be less than 49. Good news. Isn't that a usable answer? It is a solution that we can use. So you see lambda equals 0 doesn't always give you nothing, right? Here it actually generated an answer we can use. Now we do assume that lambda is not 0. And then I'm going to take equation 1 and I'm going to divide it by equation 2. Which means I'm going to get 2x plus 8 over 2y take away 8 is 2 lambda x over 2 lambda y. And this equation, we're going to rearrange it and simplify it. And at the end of it, I should be able to figure out what y is in terms of x, which is what we typically do. God, there are a lot of things I could do here. Couldn't I just cancel the lambdas and the 2's? That would be helpful. And so what I've now got is 2x add 8 over 2y take away 8 is x over y. If we do our cross multiply, 2x 8 times y will equal 2y take away 8 times x. If I distribute this, I get 2xy plus 8y. And if I distribute this, I get 2xy take away 8x. The xy's cancelled, so I'm left with 8y equals negative 8x, which means I'm left with y equals negative x, which is kind of what you expect. You expect y to be in terms of x. Okay. Now, when you have a constraint equation, which is the form less than or equal to, as we have here, or greater than or equal to, or just equals to, they all get treated the same way. You only need to look in the boundary. The lambda equals 0 is taking care of the other situation. Right? So we only need to look at the boundary now. So the boundary is that x squared plus y squared needs to be 49. That means x squared plus negative x squared needs to be 49. Which means 2x squared needs to be 49, which means x squared needs to be 49 over 2, which means x has to be plus or minus 7 over root 2. Right, when x is...
Isn't that supposed to be less than the equation?
Yes, and what I said is that in these situations, you only need to look at the boundary, so you make it equal to. The inside of the circle has kind of been taken care of with the lambda equals 0 situation. It's kind of figured that out, and so we don't need to worry about anything except what's happening on the boundary. So that's going to be that fella. Y is the negative of it, so it's going to be that guy. And when x is the negative of this, y ends up being positive this. And so what does that get me? It gives me a point that looks like this. This one gives me a point that looks like this. And I already have a point up here called negative 4, 4. So what we've done, and it takes a fair amount of work, but haven't we found 3 critical numbers? And the question is always going to be, find the maximum and minimum value of this function with this constraint. So what I now do, but I'm not going to because it takes too long, is I'm going to plug negative 4, 4 into here and get an answer. Then I'm going to plug these two guys into here and get an answer. And then I'm going to plug these two guys into here and get an answer. So I'm about to pretend I know what the answer is. You will get the real number. This guy is 39, this guy is negative 42, and this guy is plus 42. If that happened, wouldn't the maximum value be 42 and the minimum value be negative 42? And you've now finished the question. So you take these coordinates and you plug them into the optimization function, the function you're being asked to find the maximum and minimum of, and you plug that guy into here, and you get the answer. Then this guy, then this guy. The biggest one of the 3 is the absolute maximum value, and the smallest one of the 3 will be the absolute minimum value. And sometimes you can get a draw. Can you imagine 2 of them might be 42 and the other is negative 42? That's okay. It just means that the maximum value happens at 2 locations.
It looks like you had x squared plus negative x squared. How did the negative go away?
Oh,
equal
well,
to 49.
if you take negative x and you square it, it becomes plus
Mhm.
x squared. So it's x
Okay.
squared plus x squared. So now you've got 2x
So you
squared.
do distribute the squaring, which would cause it to be x squared,
Yes.
and then
So
you
you
add
do.
them. Okay.
Yeah. Did I not stick a bracket around? I did. Good. So
Okay.
when the bracket is the important part here, because that means negative x times itself, which is x squared. And
Okay. I
that's
didn't
why
know if you distributed it to get it positive before you
I
called
did.
it x squared. Okay.
Yeah. Plus, the way you say it is hard. If you say negative x squared, it sounds like I'm saying negative, long pause, x squared. What I'm really saying is negative x being squared. So the English language and pausing caused some problems there too. Those are long questions. The good news is that the process really doesn't change much. So if you get to do a few of them, you'll get better at them. I'm going to do another one. This is aversion equation 7. This is going to be my last two-dimensional one, because I want to show you how you do a three-dimensional one. There's your optimization function. Find out what values of x and find out the maximum and minimum value of this function, subject to the constraint that x squared plus 4y squared is going to be less than or equal to 1. Okay. So I know I'm going to be doing the gradient of f has to equal lambda gradient of g. Put my arrow in the wrong place, there we go. Gradient to g. And this guy tells me my constraint function. It's the x squared plus 4y squared guy. Okay. Gradient of this fella. Partial derivative of e to the negative xy with respect to x. Well, it's e to the negative xy times something. What's the missing piece? With respect to x, what's the missing piece?
Negative y.
Agreed. Would you agree by symmetry? You could probably guess that one without thinking. And it's going to be 2x comma 2y. So my first equation is negative y e to the negative xy is 2 lambda x. My
Is it always 2x, 2y? Or
no,
is
it's
it
just because that's some x squareds. If that was x cubed, it would be 3x cubed, for instance.
Wouldn't it be 8y in this
y?
case? Because we have the 4 on there.
Yeah.
There's a 4 somewhere. Oh, down in space. Yeah, I thought you were, yeah. 4 gets you 8, 12 gets you 24. It's, power roll. Yeah, thank you. You got it in time. And now I'm going to do lambda with an 8 and a y. And my third equation is basically going to be that guy. Well, technically it's less than or equal to 1, but I will be doing the boundary. But when I do the lambda equals 0 guy, I will be using the less than or equal to version. And when I do the lambda not equal to guy, I'll be using the boundary, the equal 1. So I don't want to have to write all of this twice. So that's one down. Right, now if you make lambda 0, equation 1 tells me that negative y e to the negative xy has to be 0. And equation 2 tells me negative x e to the negative y has to equal 0. And now we need to solve for what values of x and y will this be true. Okay. This here doesn't matter. And the reason it doesn't matter is that if you plug any number in for x and y, won't e to the negative x and y be a number? E to the power of something can never be 0. So what that tells me is basically the only way that's going to happen is y equals 0. And the only way that's going to happen is x is 0. So now I have to test this point. And is x squared plus 4y squared less than or equal to 1? When you do the lambda guy, you use this fella. When you do the lambda not equal to 0, you use this fellow, right? So little thing, right? Does 0, 0 work here?
Yes.
Right, so that's us taking care of the inside piece. So that's a candidate for the local max and min. Not guaranteeing it is, but at least it's a place to look. My gut feeling is that it's probably neither. I think it's just going to be a number that is in the middle. Right, so if you take equation, now we need to assume that lambda is not equal to 0. And then we are allowed to do equation 1 divided by equation 2. Can you see that it's a process? I do the same thing every time, right? With different functions, but the same process. Now, if you take this guy, you get negative y e to the negative xy over negative x e to the negative xy. And it's going to be 2 lambda x, and it's going to be 8 lambda y. Oh, that is pretty cool here. If you were wondering what's going to happen to that, don't they cancel out?
Yes.
And the lambdas always cancel out, which is why we do this. And and the negatives cancel out. So I'm going to have y over x. And I can cancel that a little bit, and it's x over 4y. Cross multiplication, 4y squared will equal x squared. I did a shortcut to this, but I'm just going to do it the usual way. Y squared is a quarter x squared. That makes y plus or minus 1/2 x. You're comfortable with y in terms of x, which is your kind of goal. Now you take that guy, let's say y equals positive 1/2 x, and you put it into x squared plus 4y squared equals 1. And that's going to get me x squared plus 4 lots of that guy squared equals 1, which is going to get me x squared plus x squared is 1, which is going to get me x squared. Phew. There. Now, if I plug negative 1/2 x in here, can I just tell you, you're just going to get the same two answers? Now, when x is equal to 1 over root 2, y is 1/2 of x, so it's going to be 1/2 of this guy. When x is equal to negative 1 over root 2, y is going to be 1/2 of this guy, which is that fella. So that gives me the points, and this one gives me the points. Should start putting circles around all the points I've got. That's this one and this one. Now, I'm not finished. If I went through the y equals negative 1/2 choice, I'd end up with this result. And that would give me, when x is this fella, y is negative 1/2 of it. And when x is this fella, y is negative 1/2 of it. So that gives me 2 more points. So you check out that one, these two, and these two. So you can imagine that you've got 5 points. This one, this one, this one, this one, and this one. And you plug it into here. And the biggest answer is the absolute max, and the smallest answer is the absolute min. And that would take a big chunk of time. But it is doable. So although I'm saying, okay, I guess I shouldn't just say it. Take 0, 0, for instance. This fella will be e to the negative 0 times 0. He will be e to the 0, he will be 1. If I randomly just pick one of them, suppose I want to check this guy then. The value of the function will be e to the negative x times y. That will be e to the negative 1/4. Or if you want to call it e to the 1/4, or you want to call it the 4th root, whatever you like. That's what it's equal to. Now, that is not as big as 1, is it? So if that was the only two guys I had to choose, wouldn't the maximum value be 1 and the smallest value would be this guy? So you evaluate at each of those 5 distinct points what this function here is equal to. Now, if we had twice as many hours, I'd actually do that kind of question all the way from start to finish. But we don't. So I guess you'll just fill in the gaps. So let's look at hopefully 2 examples of a 3-dimensional one. So suppose we're being asked to find the maximum and minimum value of this function, x, y squared, z, subject to the constraint x squared plus y squared plus z squared equals 4. So this is the constraint. Which means the g function now is x squared plus y squared plus z squared. The gradient of f is going to be lambda times, let me do it again, the gradient of g. The gradient of f, let's see. Differentiate with respect to x. Differentiate with respect to y. And differentiate with respect to z. Is going to be lambda times this guy. So it's going to be lambda times 2x, 2y, 2z.
Shouldn't you have 2x in front of, with respect to x, in front of the y squared z? Or, oh no, it's x. I thought it was x squared, sorry.
Are we good then? We good?
Yes.
Right, that's okay. It's worth checking, you know what I'm like. Right, so we're going to add 3 equations now. The first one is that y squared z is going to be 2 lambda x. The second one is going to be 2xyz is 2 lambda y. The third equation is going to be xy squared is 2 lambda z. And your fourth, the last equation, is going to be this guy. Now, have you noticed that this constraint is an equals, which means it's going to be equals when lambda is 0, and it's going to be equals when lambda is not 0. If this had said less than or equal to 0, when I do the lambda equals 0 check, won't I make this restriction less than or equal to 4? And then when I do the lambda not equal to 0, I only use the boundary. Right? Do you know that little subtle difference when it's less than or greater than? The lambda equals 0 uses the whole restriction. But when you do lambda not equal to 0, you only need to look at what we call the boundary function. Well, if you make lambda equals 0, plug it in here and you get y squared z equals nothing. Plug it in here and you get 2xyz equals nothing. And plug it in here and you get xy squared equals 0. And so here's the question. What solution for x, y, and z will these 3 things be true at the same time? There's only one combination of numbers where all 3 are going to be true.
Zero, zero, zero.
Right. Can we just do that as obvious? I guess if you wanted to do it, strictly speaking, if this is going to be true, shouldn't y be 0 or z be 0? right? If y is 0, that's okay. But then you got the y equals 0, and you've got to figure out what the other two are, and then you get the x and the z. So we're just taking that one as it's done. Otherwise, we could get into all sorts of messy math just to find out what we already know. Now, how you tackle 4 equations is a little bit different than how we tackled the 2-dimensional ones. So you assume lambda's not 0, and you do 1 divided by 2. That's a good start. So that's going to be y squared z over 2xyz is equal to 2 lambda x over 2 lambda y. The z's cancel, one of the y's cancel. So I get a y over 2x equals x over y. If I rearrange that, won't you get y equals 2x squared? And so won't y be plus or minus 2x?
Root 2x.
Say again?
Root 2x.
Well, if you take the square root of x squared, you get x.
Yeah, but 2 will not.
Oh, root 2. Oh, sorry. Yes. Root 2 of x.
There you go.
I got you. Right. Well, that's good news. Because what we want in this question is y in terms of x. That's what we always want in all the other questions. Now I'm going to take equation 1 and divide it by equation 3. And equation 1 gives me y squared z over x y squared. And it's going to give me 2 lambda x over 2 lambda z. I can handle that. The y squares cancel, and I get a z over x. The lambdas and the 2's cancel, and I get x over z. And so I get what? Z squared equals x squared. So won't that make z plus or minus x? I'm good with that. Now, the constraint equation, x squared plus y squared plus z squared equals 4. I am going to cheat a little bit. Don't I know that y squared is 2x squared? And don't I know that z squared is equals x squared? So this is going to be x squared plus 2x squared plus x squared equals 4. Are you happy about how I just saved some working by not using this version, but using the one above it? Right, that y squared can be replaced by x squared, and that z squared can be replaced by x squared, right? Now, you add these together, you get 4x squared. And doesn't that get you x equals plus or minus 1? Agreed? Now, you have to kind of work backwards here to try and find out what are the corresponding values of y and z in this case, right? So, if x equals 1, and then x equals negative 1. When x is equal to 1, won't y be either plus root 2 or it could be negative root 2? And won't z be won't z be either plus 1 or negative 1? And if you put all of these together, you'll be amazed by how many there are. There's a 1 root 2 1. There's a 1 root 2 negative 1. There's a 1 negative root 2 1, and there's a 1 negative root 2 negative 1. Do you see that there's actually 4 answers in that relationship? And then there's another 4 from here, which I'm not going to do. And then we've got 0, 0, 0. So altogether, there are going to be 9 different points. Have fun. And those 9 different points, you will calculate x squared, x, y squared, z. And the biggest answer is absolute max, and the smallest answer is the absolute min. if you look really carefully, you can actually predict that a lot of these combinations end up being the same answer. So you don't really need to do 9. You can look at it and say, look, I know that one, that one, that one, and that one are all going to be the same answer, so it doesn't matter. I only need to do it once. But theoretically, there are 9 places to look. Can you see this question is going to be huge? And the end part is just slow. It's not hard. I mean, you can find the value of a function. It's just doing it 9 times is a pain in the butt, right? It's not a hard thing to do. It's just a time-consuming thing to do. Okay, let's do another 3D one. Okay, where am I? Oh, we got a puzzle one to do. Question 8. Here is a plane. We want to find the shortest distance. And it's going to be the shortest distance to that point. So if you imagine this is what X, Y, Z looks like, and over here you've got the point 3, 0, -9. And there's going to be a little point here called Q, which right now I'm going to call X, Y, and Z. It's exactly the same question as we did in the previous section. We're just going to do it in a different way. Now, we're trying to find the length of PQ. Well, the length of PQ is the square root of X take away 3 squared plus Y take away nothing squared plus Z add 9 squared. This guy here is our optimization function. And this fella here is actually the constraint. Now, if I tidy this up and I pretend that the square root is gone, all we get is X minus 3 squared plus Y squared plus Z plus 9 squared. And it's probably just worthwhile leaving that alone. And it's subject to the constraint that X plus Y plus Z equals 1. So the gradient of F is going to be lambda, the gradient of G. If you rewind. Can you remember last time that if you square something, the place where this is biggest or smallest is the same place that this is biggest or smallest? Right, so that's how I do it. It's just a lot easier maths to use this guy as your optimization function. The guy you're trying to find the smallest answer to. Now, let's see what we have. With respect to X, this guy is 2 lots of X minus 3. With respect to Y, this guy is 2Y. And with respect to Z, you've got this guy. And it's going to be lambda. Oh, you can't get much nicer than that, would you agree? 1, 1, 1. So when I match up the equations, 2 lots of X minus 3 is going to be 1. 2 lots of Y is going to be 1 lambda, I should say. It's going to be 1 lambda. And lastly, 2 lots of Z add 9 is also going to be 1 lambda. Now, let's do the assume that lambda equals 0. And I'll try and cut some corners here. If lambda is 0, would you agree that the only way that's going to happen is if X is 3? If lambda is 0, the only way that's going to happen is Y is 0. And if lambda is equal to 0, the only way that's going to happen is when Z is negative 9. Agreed? Now, that means that we are going to test that point, and we're going to test it against the constraint function, which is that. And does 3 add 0 take away 9 equals 1? And the answer is no, so you can't use them. Remember, it's got to pass the constraint function, right? It's got to pass that. So now I can do the assume that lambda is not equal to 0. And I'm going to take equation 1 and divide it by equation 2. In this case, you're going to get this guy over this guy is lambda over lambda. And that makes x minus y thingy bob equal 1, which makes y equal to x minus 3, and that is good. Because what we want here is y in terms of x. And in a few minutes, don't I want z in terms of x as well? So I'm now going to do equation 1 and divide it by equation 3. And that gets me 2 lots of this guy is lambda and 2 lots of z plus 9 equals lambda. If I cancel the 2's and cancel the lambdas, I get x minus 3 over z plus 9 equals 1. If you do a little cross multiply, z add 9 equals this. That makes z, I hope, that guy. Going a little bit quickly here, I apologize for that, but we're kind of time crunch going on. Are you comfortable with 1 divided by 2 gives you y in terms of x? 1 divided by 3 will give you z in terms of x. Now, what do I do with all those guys? I plug them into the constraint function. And according to the constraint function, x plus y plus z must be 1. So x plus this guy plus this guy must be 1. So what's that? 3x take away 15 must be 1. That makes 3x has to be 16. That makes x 16 thirds. That means y, which is x take away 3, is x take away 9 thirds, which gives me 7 thirds. And z has to be x take away 12, which is this guy take away 36 thirds, which gives me that guy. And so there is only one solution that came out of this problem. That is the coordinates of the point on the plane which is closest to the Q. Are we finished? I mean, I found the coordinates at that point, right? That guy there is 16 thirds, 7 thirds, and negative 20 thirds, right? I found them, but was that the answer that we were looking for? We were asked to find the shortest distance.
So we have to put it back into the distance formula.
Which is this ugly, bluggy thing here. I am not going to do that, but can you imagine the heartache you're going to get when you plug it in here? I mean, it's just number crunching, isn't it? But it's going to be ugly things with fractions squared and added. It might come out right now. You know, I've seen them come out really nice. It might come out as 15 thirds when you're finished. But you will plug x 16 thirds in here, y 7 thirds in here, and z negative 20 thirds in here. Square them all, add them all up and take the square root. I'm pretty sure the bottom number is going to be 3 just because of the math. Right? Everything's going to be something thirds being squared, so it's all going to be something ninths. So they're all going to add up to something ninths. So I know it's going to be, whatever the top number is, I don't know, but it's going to be something over 3. That would be my guesstimate.
Can you please go over the answer for when we assume lambda was equal to 0? Why can we use that answer again?
Because when I do the constraint function, which is x plus y plus z equals 1, 3 plus 0 plus -9 does not equal 1. So
okay.
that solution is non-usable. Sometimes
Okay.
it is. You've seen at least one question. Didn't we see one question today where the lambda equals 0 did give you a usable answer, right? So it can happen, but not this time. If you think about the geometry of this question, it's kind of obvious before I even tackled the question that there can be only one answer. Would you agree that if you put a point in 3D space on a plane, isn't there only going to be one place on the plane that's shortest, right, is nearest to it? Not that you need to know this, but do you know that if you look at that, wouldn't that be at right angles to the plane? Right. Doesn't make any difference to what we've done, but that's what would be going on. Okay, perfect timing, I hope, which is why I was doing the time crunch thing. We are going to have to spend a little bit of time talking about your test. And okay, where the heck are you? Right, give me a second to open the right window. I got windows left, right, and center, and I don't know where the heck I am. Okay, I can close all those windows. I got this window. I do have this window. Does this window have what I need? Close that one. Close that one. Close that one. Okay. Your video is not up yet. Canvas had an issue yesterday, or I would have had your previous Zoom video up and running. But if you bear with me, here we go. Right, and this is my version of the thing. But if I click on here and I do Students View, yeah, that's what you're going to see, right? That'll be the thing. I've put a separate module here that's basically telling you everything that you need for your test. So for instance, if you click on this link, please work, can you see a link to download Adobe Scan? I don't know how Zoom tackles that, but this gives you some information, a little video, and then if you click on that, hopefully the link is still good. It takes you to a piece, an app that you can download called Adobe Scan. And basically, you use your camera to take pictures of your working. And this program will turn these into a single PDF. And if you click on that little video there, which I guess I could do, fingers crossed, nothing weird happens with Zoom. Canvas has been a pain in the butt lately. Right, yeah, okay. The video does work. Choose a different browser. If Google Chrome doesn't work, choose, Microsoft Edge, whatever it is. Basically, you get that program, and then you'll click on this fella, upload working for test 1 here by, was it 10:30? I think I'm wrong here. Yeah, 10:30. I'm right. Click on it. And submit assignment. Choose file. There's my French jokes. Choose. Yeah. You don't think that I have to do things. Do you know one of the things I have to do is they keep sending me to things and I have to go online and do some online training. So I've had ethics training, I have sexual harassment training. When I first started here, drifting a little bit, HR came and told me that I had to go to sexual harassment training. And I said the wrong thing. I went and said, is that so I can be better at it? They didn't appreciate my humour. But nonetheless, anyway, you click on the PDF, you say okay, boom, and it's done. Submit assignment. Right, so can you imagine you've already got on your computer the PDF of your working that you've used in Adobe Scan, right? You take Adobe Scan. What I would do is in Adobe Scan, it gives you the ability to send it. I'd send it to my email address. Then I go to my email address and I download it and I put it somewhere dead easy. I put it right on my desktop, so it's easy to find. And so when I did that, you know, choose the file thing, if you choose desktop, you can just click on it and boom, submit assignment. Does that seem reasonably straightforward?
So pretty much you want a screenshot of our work, pretty much.
Yeah, and you got to think about showing me as much as possible in case you screw up. Because if I don't see working to a question, if I has this question here, right, this one we just did, right, wherever that is, right. If I just see the answer is the minimum distance is 42, and that's what you typed into WebAssign, and it was correct. But I do not see any working. What's the assumption I'm going to make?
We cheated?
Yeah. You can't do that in your head. Not in a billion years could you do that in the head, unless you're one of these savants that, you know, the world throws up every 50 years, right? Since none of us fall into that category, don't you have to do working to get all these answers? That's what I need to see. Now, if the answer was 42, but you wrote 24 down, WebAssign will give you a big fat 0. But if I see you're working, you'll get virtually all the points, because I can say, yeah, for some reasons you switched the digits at the end. Or do you know how one of the questions I forgot a 2 or whatever it was, an 8? If I went through that process with the numbers I've got, the answer would be wrong, but wouldn't the process be correct? When the only thing I did was being careless about reading a number. So you can imagine in a situation like that, if I was grading me, I'd probably get 90% of the points, because the only mistake I made was one little trivial mistake where I wrote a 2 that should have been an 8, right? I did one little thing, but the process was right. So that's why we want it. 1, to stop cheating, and 2, so I can give you points for partial credit.
Okay, I'm a little confused now.
Yes.
So you want us to show our work then? Like
Yes.
how we, okay, and is there a place to do that online? So how?
Oh, let's rewind that.
So how
When
are we
you,
supposed
yeah,
to
when
show
you
the
are
whole
finishing,
work?
right, let me start from top. When you finish your working, you will get your phone and you'll use Adobe Scan and take pictures of your working. This program called Adobe Scan takes those pictures of your working, converts them to a PDF. You will upload that PDF into this program here on Canvas, and that's how I get it. That makes sense?
So are we downloading then the test then? Is that what it is? Am I writing on it?
No.
You are doing the work on paper, I believe. And once
Yes.
you've done all that, you're going to use the scanning app to transform it into a PDF and turn it
Okay.
in.
Okay. All right.
Okay, I guess I missed the word paper, but
Okay.
words can make a big difference. Yeah. WebAssign is where you'll find your test. You will turn up at 8 a.m. Well, say you turn up 10 minutes before 8 a.m. because there'll be a Zoom meeting then and I'll see you. And at 1 minute or 1 second past 8, when you go to WebAssign, the test will be there. So when you look at it, you'll see the questions, just like homework, and there'll be a box for the answer. And I suggest strongly that you still do WebAssign, right? You still fill in the box with the answer. It's a way for me to keep track of what questions you get, because WebAssign will randomize the questions. So, gee, you can't phone up Lindsay and cheat and say, Lindsay, I'm doing question 2. What's your answer? Because Lindsay's answer won't be your answer, because Lindsay's question will have different numbers. And they're also randomized within the question. So her question might not even be quite yours. It'll be similar difficulty, but not the same. So what we're trying to do here is make the playing field as level as possible. So I'm trying to make people who cheat, I'm trying to make it as hard as possible, so the rest of us, we're all getting the grade we deserve. Right.
Will we have a formula sheet at all or anything, or?
I have a formula sheet. I don't know if you want. The rules are anything that's physically written you can use. So why don't you write on a piece of paper all the formula you think are useful that you want to use? You may want to use a copy of the unit circle in case you're a bit rusty on exact values of angles. Occasionally you need to do that. Write cheat cards, you know, like a short list of the steps needed to do what we did today. You know, make lambda 0, do this. Make lambda not 0, do that, right? And so when you see, if you see one of those questions, you look at your check card and it says, okay, right, that's the order I'm going to do that. If it's physically written down, it's cool. You're not allowed to communicate with homework, you know, tutoring, and say, can you help me with this question? That's cheating. You can't go onto websites and you can't use software. Right? You know, there's a lot of software you could just plug in, you know, do this for me and it would do it. So if I don't see you working, that's where you were cheating, right? Any other questions?
Not a question, but a statement. If
Go
you
for
don't
it.
want to download a PDF converter, you can just paste it into Paint and then hit print. And then your print options, there'll be a Microsoft Print to PDF, and it'll save that picture as a PDF.
Did you pick that up? So you just take your pictures like normal, just like a camera picture of, you know, your cat, and you put them into Paint. Did I get that right?
Yeah,
Did
Paint,
you say?
and then
Right,
print.
so yeah, and then when you do your print, do the print as a PDF choice, and that's another way of getting it down. Right. Some of you have got scanners on your printer, don't you? Some of you. Do you know you could just put all your paper, all your working onto your printer and do a scan of it, and that would get you the PDF. I really don't care how you get it to the PDF form, right? That's not too important to me. As long as when it's finished, it's a PDF that you can upload into Canvas.
Professor?
Sounds good. Yes.
I just wanted to add, in case it's helpful to anybody, graph paper. Graph paper does not work very well with Adobe Scan. Just so people know.
It just doesn't show up. It kind of disappears.
Yeah, I think plain white paper is probably your best bet.
Right. So for a good clear scan, clear white paper. There's some advice from someone who's done it. Travis, you have done this before. It's not a big deal, is it, to upload your work in?
No, but I had to scan mine a couple times because I used graph paper. So.
Okay.
Other
So
than
you've
that-
learned that lesson.
Yeah, but other than getting a good scan, I didn't have any problems doing it.
Right. If you're not sure about it, why don't you do a dummy piece of paper and write hello on it? Use the Adobe or whatever method you're going to get. Go to this assignment and upload it and ask me if it worked, and I'll go and check it. You know, you can go back and upload it again and again in case you forgot a page. You know, but you have to do it by 10:30.